Hi, in this session we will discuss about the fundamentals of hypothesis testing, specifically for one sample hypothesis test. In the first section, we will discuss about the basic principles of hypothesis testing. Let's start with the definition of hypothesis terminology. Hypothesis is a claim about a particular parameter of a population. Say, we have a population of Indonesian citizens, and we would like to describe the population in terms of its height. We can state several parameters to describe the population, such as the mean of Indonesian citizens' height, standard deviation, proportion, and so on. A hypothesis statement can be as simple as the mean height of Indonesian citizens equals to 165 centimeters, or you can also state that the mean height of Indonesian citizens is less than or equal to 165 centimeter, or you can also state that the mean height of Indonesian citizens is greater than or equal to 165 centimeter. Next, we are going to move to the definition of the hypothesis test terminology. A hypothesis test evaluates if a population parameter is equal to a hypothesized value of sample statistics. Note that previously we have put an example of Indonesian citizen population, and we have put several examples of hypothesis statements considering the mean height of Indonesian citizens. What we are doing in the hypothesis testing process is that we pick several respondents as a sample, and then we analyze the statistics of the sample. If the value statistics of the sample is close to the stated hypothesis, then we can accept the null hypothesis, or we can accept the previously stated hypothesis. But if the value of the statistics of the sample is far away from the previously stated parameters, then we have to reject the null hypothesis and state that the alternative hypothesis is closer to the truth than the previously stated hypothesis. Let's discuss the basic principle of hypothesis test with an example. Recall that previously we have discussed an example concerning the Indonesian populations, and we have put several examples on how to define the hypothesis statement. In this case, let's use the null hypothesis as this. The mean height value of Indonesian citizens equal to 165 centimeters. The alternative hypothesis statement is stated as the mean height value of Indonesian citizens is not equal to 165 centimeters. How can we test this? Well, from the population, we can pick several respondents as a sample, and we simply calculate its statistics. In this case, the mean. What we do is we compare the mean of the sample with the mean of population. If the sample's mean lie nearby the mean of the populations, or if the mean value of the sample lie in the region of their non-rejections, then we must not reject the null hypothesis. But if the mean value of the sample lie on the region of rejections, then we have to reject the null hypothesis. Simply say that if the test statistics falls into the region of non-rejection, this one, then you do not reject the null hypothesis. Conversely, if the test statistics falls into the region of rejections, then you must reject the null hypothesis. Let's discuss about the concept of type 1 and type 2 errors. A type 1 error occurs if you reject the null hypothesis, but actually the null hypothesis is true, and the null hypothesis should not be rejected. The probability of a type 1 error occurring is denoted by the symbol of alpha, or the level of significance. In other words, the level of significance is the probability of committing a type 1 error. A type 2 error occurs if you do not reject the null hypothesis, but actually the null hypothesis is false and should be rejected. The probability of making type 2 error is denoted by the symbol beta. In tabular manner, we can see the type 1 error occurs when you reject the null hypothesis, but the actual situations, the H null is true. The probability of making this error is denoted by alpha, or the level of significance. Conversely, the type 2 error occurs when you do not reject the null hypothesis, but actually the H null has to be rejected. Let's see the application of this alpha concept in following example. Let's go back to our example. Say that previously we state that the null hypothesis stated as the mean height of Indonesian citizens is equals to 165 centimeters, and the alternative hypothesis is stated as the mean height of Indonesian citizen is not equal to 165 centimeters, then if we see the alternative hypothesis, we can see that the alternative hypothesis uses the inequality signs. This means it is not precisely defined whether the sample's mean will be greater than or equal to the population's mean. It's just the inequality signs, which means that the level of significance or the error that we are choosing has to be divided into two directions, into the right side and the left side. This means that if we use the inequality sign as the alternative hypothesis, we do the two-tailed hypothesis test, meaning that the error will be distributed evenly to the right side and the left side. Following the discussion of the two-tailed test concept, now we turn to the one-tailed test concept. Note that the null hypothesis and the alternative hypothesis statement can also be directional, which means the error term or the level of significance we are choosing are also directional. For example, at this part, we state the null hypothesis as the mean height of Indonesian citizen population is less than or equal to 165 centimeters. And the alternative hypothesis is that the mean height of Indonesian citizens is greater than 165 centimeters. So these statements only concerns whether the sample statistics is actually larger than the proposed critical value, which means that the error terms is only put in one direction. This is different with the previous example, whereas the error terms are evenly distributed, because we don't really care whether the alternative findings will be larger or smaller. That's why in the two-tailed test, the error terms is divided into both directions. But in this specific context, using the larger or the smaller smaller symbol, the error terms is only put into one direction. For the one that has an alternative hypothesis testing, which states that the mean population is larger than a specific value, where the error terms in the right side, we call it the right tail test. Conversely, if the alternative hypothesis statement state that the mean population is lower than a specific value, then the error terms that we are testing is at the left side, which means that we have the left tail test. Both the right tail test and the left tail test is considered as a one tail test. Finally, we reach the end of section 1. Congratulations! In the following sections, we will work several exercises so that you can apply the theory of hypothesis testing to the case examples. See you in the following sections.